Hi, let's talk about polynomial division. So as you can see here, we have y to the third power plus 11y squared minus 10y plus 6, and we want to divide this by y plus 2. And there's two ways that we can divide this out. The first of which is traditional division, where we have the numerator here and the denominator here. And we want to ask ourselves, what should we multiply this value here, the y here, to get y to the third power? And the answer would be y squared. And so now we multiply y plus 2 by y squared and bring it down here. So what I'm saying is y to the third power plus 2y squared. So just multiply those two out and brought it down. And now we want to subtract. That becomes a negative, and this becomes negative 2. So these cancel out, and now we have 9y squared, and we can bring this value down, so 9y squared minus 10y. And now we want to ask ourselves, what should we multiply y by here to equal 9y squared? We always think about the leading terms. So that would just be 9y. So we multiply y plus 2 all by 9y, each term, so we get 9y squared plus 18y. And now we subtract. So that becomes a negative. This becomes a negative. And these cross out. And this will become negative 28y. Now we can bring down our 6 plus 6. Now what should we multiply y by to get negative 28? And that is, or negative 28y, and that is negative 28. So we have negative 28y minus 56. Now we subtract, which means these two become positives. That cancels out, and we're left with 62. And now since the degree of 62 is 0, and the degree of this statement, y plus 2, is 1, we can't do any more division this way. So we simply write our remainder as plus 62 over y plus 2. And this is our answer. Now let's think of a completely new way of doing things called synthetic division. So for synthetic division, we need to make sure that our denominator here is a linear factor, which it is because it's y plus 2. That is a line. And plus, our y right here has a degree of 1. So this is definitely a linear factor. So now we want to think about y plus 2. What should we plug in for y to make this expression equal 0? And that is negative 2. So we put in negative 2 in our box up here. And so along here, we want to put our coefficients for our numerator. So 1, 11, negative 10, and 6. And keep in mind, if one of these values were to equal 0, say if we had a 0 right here and we just had y to the third plus 11y squared plus 6, we need a place value right here for the y to the first power term. Don't forget your placeholders. So now we want to synthetically divide. And to do this, we first bring down our 1 down here, and we multiply by negative 2. So multiply by negative 2, we get negative 2. Now we add, get 9. Now we multiply by negative 2 once more, get negative 18. Now we add, that's negative 28. Now we multiply, that's 56. Add once more, that is 62. And so now we see that these numbers here will actually be our coefficients of our quotient right here. And so how do we figure out which term of which degree of y pairs with each of these coefficients? Well, if you look here, you see that we have a polynomial of degree 3 divided by a polynomial of degree 1. And we know that whenever you take a polynomial of degree, say, n, and divide it by a polynomial of degree 1, you will always get a polynomial of degree n minus 1. So this must be 3 minus 1, so 2. So y squared plus 9y minus 28 plus, and so this has degree of 0. This will be our remainder right here. So we go 62 divided by y plus 2. And that is our remainder. So, as you can see here, not only have we found the correct answer that we also found doing the long way, but we also found it much faster and much more efficient. So this is why synthetic division is extremely handy when you're working with polynomials.